You got an idea, and I think Hey everyone, what's up and welcome to the Phil Studio. Today is a great day because once again the red salamander got pissed off. I'm probably sure that every guitarist experienced this problem once in their life. Unless you already have your pedal board all set up. We all know what is the mess of plugging all our power supply to our hundreds of pedals. Today we're done with this shit. We're doing our own daisy chain power supply for pedal. And before we start, three important points so you don't burn anything. 3 important points. First, voltage. Voltage. Make sure that all your pedal works on the same voltage. So let's say you have a pedal that works with a 9 volt supply and another one with 12 volt supply.
Watch out, kids!
Alright, so if you don't know what voltage your pedal works with, I suggest you check your instruction manual on page 2 or 3, or you check out on Google, or else just ask me in the comment of this video and it'll be my pleasure to Google it for you. Second point, the current. I will let Nelek Newton explain this for you. Maybe it's a... Oh, oh, hey there. Okay. What about current? So since we're powering many devices with one power supply, all our load are in parallel. By mean, the voltage will reach all of the devices with the full capacity, or so. 9 volt, 9 volt here, 9 volt here, 9 volt here, 9 volt here, 9 volt everywhere. 12 volt, 12 volt here, 12 volt here, 12 volt here, 12 volt here. But the issue here is current. The current will spread according to the need of each load. In parallel, the current is cumulative. Let's say our power supply can supply 1 amp of current, and this load requires 0.5, 0.5, and 0.5. Boom! Power supply explode because you draw 0.5 plus 0.5 plus 0.5 equal 1.5 amp. This is too much for the capacity of this power supply. So make sure you don't overdrive your power supply with the load. Let's say this one drives 0.2, 0.2, 0.2, and another 0.2. Power supply survive. 0.2 plus 0.2, 0.2 plus 0.2 equal 0.8 amp. This is good for. Usually you can find the specification on the back of your devices, but if you cannot find it in the instruction manual, like Field mentioned, you can ask in the comment and it will make a pleasure to Thank you, Nelek Newton. And for the last and the most important point, it's all about polarity. The polarity of your center pin. I'll explain more in the detail what I mean about polarity supply when we're going to solder the connector, but make sure that all your pedal has the same polarity. Either it's the center pin positive or the negative center pin. Make sure they all work the same way, or you will fry your stuff or damage your equipment. So let's go. Okay, so we're at the bench, and here's a little list of the material you will need. First of all, like usual, your solder, your soldering iron. Make sure it's really hot. Here I bought a little power supply which provide 9 volt up to 1 amp. And after some calculation, I realized that 1 amp was enough to power all my pedal. So I have most of my pedal in hand. You can see here, you have the information on the polarity, and in the Bose pedal, the center is negative. I have some power jack connector here that you can solder. I got myself 6. I think it's enough for my pedal. In the best case, you could use the 90 degrees angle connector. In my case, I bought the regular one. They were really cheap in pack of 2. So let's take a close up at this one. You will see that this pin here is connected to the external part, and here is the center pin. I'm just gonna probe it to make sure, and this is something you can do yourself with your multimeter. Always good to double check. So we have the external, no short, center, good. So everything is working fine. Now we're going to test our power supply, because you want to identify your positive wire in there. Here we have a center positive, but it doesn't really matter since we're just gonna change the plug and cut the wire. So cut the wire, your cable, to the desired length. In my case, this would do the job here. So I take my cutter, cut this here. Make sure the power supply is not plugged when you cut your wire. And if you replace the wiring, your cable, make sure the gauge of the wire is big enough to handle the current, the capacity of your power supply. So we're gonna trim the wire here. And there comes ND to have the third end. One to the negative probe, and another one to the positive probe. And we're gonna plug this power supply into the wall. Make sure these wires are not touching each other. So now your multimeter is in a DC mode. We're gonna plug this one here, this one here. Now we have -13. Gonna change the probe. We have 13, so this wire is the positive one, and this one is the negative one. 13 volt, and it's written 9 volt. That is really bad. We're gonna put a load to test. To test if
the voltage drops when we plug a load. 10.4 volt. This is really bad. This is really bad. Yeah, that sucks. Because I want a clean 9 volt in my case, but I don't have one. And I don't want to break my pedal. So we're gonna check and see if I can find a real 9 volt supply. Okay, great. I could finally find a clean 9 volt supply. And what is great is that it can provide up to 1.3 amp. So I'm gonna be able to add another pedal to it. And it came with this 90 degrees angle connector. So I'm gonna add it to my chain. Okay, now that we have identified the polarity of our wire, I'm gonna put a little tape here and make sure to identify it. This is the positive. So I'm just gonna write a plus here. Okay. Now, just unplug the power supply. Make sure it discharge. Stay charged for a bit. Okay. You can unplug your probe. Now we can start working. This little build will require a lot of heat shrink, so make sure you have some spare around and a bigger one to wrap both wires together. All right, we'll take the blue one. It's beautiful. Okay, so I just trimmed the wire. What you will want to do is to cut another length of wire. Make sure you have enough space to plug between your pedal. So let's say 8" is good. And you can cut another one, same length. This is not bad. So we're gonna trim this one, the new wire. Make sure you have a good length of wire because you will want to twist it with this one here. Okay. We have the positive here, both positive, both negative. Oops. Then you take your connector here. Hold it down, Johnny. Thanks. That's good. And double check again. The negative is the center, positive, external. So what you might want to do for now is to thin the connector here with some solder. Just apply a little bit of solder here. And here. Just a little bit. Make sure your tip is clean. Clean the tip of your soldering irons often. Okay. And then we're gonna tin the wire, the twisted wires. This is just gonna make the soldering so easier. Don't breathe that stuff. Okay. Now what you don't want to do is solder your wire right away. Remember that little plastic isolator? Yeah, but you're gonna pass the 4 wire in there. Don't know if it's... Yeah, you can do it. Don't worry, you can do it. And make sure you can identify the positive in that big mess. Bacalao. So the positive is this guy here. So you're gonna want to solder it there. Make sure you can clip. You can clamp a little bit. Don't want to squeeze this so hard around the wire isolator. Now we have a good and clean solder here. Well, it's clean. Confirm. Next. Gonna do the same for this one. And I think this is where you will want to apply some shrink. Some shrink. Yep. Slide it. Solder. Make sure you get it right. We'll add a little bit more solder here. Great. Yep. Get it done. Easy. That's a pretty nice and neat job. So we have the shrink here. This will avoid any short between the positive and the negative. I'm really happy with that. Now take your heat gun to heat the shrink. Make sure you have your heat gun. And what we can do here just to secure a little bit more the wire, we're gonna pry a little bit here and here. Make sure you don't squeeze too tight. That's it. Now we're good to screw back the plastic isolator. Good. Now we have our first connector. We're gonna have to redo that like 6 times to complete the chain. So make sure you always identify your positive. Positive is this one. We're gonna do the same thing with another and another and another. So we're just like soldering the power cable in parallel, the negative line and the positive line. So we just do a little loop. I've been skipping a lot of the process because it can be a really long process, but once you will have done it, you'll be really happy with the result. You want to do it once, but you want to do it good. So we have 3 connector yet, and here's the wire for the 4th one. I think we'll do the 6th one, 6 of the connector plus the 7th here, which is the angle one. And after we'll be done, I'll show you how to test your daisy chain before plugging it into your pedal. So you make sure you double check your work before you plug anything. Okay, so we're about to solder the last connector with the 90 degrees angle connector, which is the end of the chain. But what you want to do before is to identify your external, which is still the positive. This wire is the positive here, and we're gonna double check that we have the right positive here. This one. So you're gonna twist these 2 wire together, and these 2 together. Okay, so before you plug your brand new power supply, we're just gonna test all of the plug, and you don't need to manually probe all of the plug. Since they are in series, you're gonna check your first one with your last one. Clean up the space a little bit. Yes, like that. Okay, so this is my first connector. This is the last connector of the series. We're gonna probe both negative, the center part. Okay, so I have some connection. And then the external. So this is good, but this just confirms you that all your connectors are chained together. So the current will go from the first one to the last one. But this doesn't prove that there is no short. So if you want to check if there is a short, just probe the negative and the positive. You should read some voltage. Sorry, you should read some resistance here. And the resistance should grow because there is a capacitor that you're an output capacitor that you're charging right now. So we can test the connector, the power supply. You plug it in the wall. So didn't explode. That's good. Now we're gonna check the center. We still have 9.2 volt here. 9.2 volt here. Looks fine to me. And I know you could buy yourself like a pre-made cable like that, but I think mine just look as professional as one that you would pay like an expensive amount of dollar. So this one is working. This one will not work because there is a power on switch on the jack connector. I can see that this one is powered up. So I'm really happy with the result. Hey everyone and musicians, so I really hope you enjoyed the process of making your own daisy chain power supply for your pedal, bass pedal. And overall, this project costed around, let's say, maximum of $20 Canadian dollars, and it took about 45 minutes to an hour depending on your speed. You can see that this one is like really well made, so it will last like thousands of years. And let me know in the comment if you tried it and what you're powering right now with your project. Can't wait to see you next time. Ciao.